We're meeting to talk about the science cases and the things that we will do with GMT integral field spectrograph in the 2020s when we actually get to build the instrument. And the reason we have to do this is so that we design the instrument so that it actually fulfills the science goals of the community. So we've got together people from around the world who are all members of the GMT Partnership, and we'll be talking about the sorts of things that they want to use the telescope for, and then we'll make sure that our instrument is able to deliver what they want to use it for.
Here we see, I think this is the symphony data from the VLT, and this is the NIFS instrument, imaging from Magellan.
I've been building big instruments like this on big telescopes for some time now, so I've built a similar instrument on the Gemini telescope in Hawaii, and I've been using it, and I get great science out of it. And combining the big telescope with adaptive optics that corrects the blur from the Earth's atmosphere means that you can get really sharp images and learn a lot about objects that we just didn't know about before. So the whole idea of GMT and this particular instrument is to use the adaptive optics to get really sharp images. And with GMT, because it's such a big mirror, we collect a lot more light. So the instrument does the really sharp stuff, but it also collects more light and gives us similar resolutions to what we currently get on the 8-metre telescopes. And so we'll be able to do fainter galaxies and understand more typical objects. And then we get a lot of information about the structure of galaxies and how they formed. We can look for planets around nearby stars and actually measure the spectrum of the planets, so we get to understand the sorts of planets there are. And a whole range of things where getting this extra resolution really makes a big difference to how we understand the physics of what's going on in those objects.